In this part of the notes, we're going to look at the second method for simplifying complex fractions. We're going to multiply by the LCD, or least common denominator, of all the little fractions, and then we're going to multiply by that clever one. So in example 2a, we have two denominators. The least common denominator is 3n, so we'll multiply the big fraction by 3n over 3n. When we multiply to each term, this is like multiplying a fraction to a whole number. The fraction, the whole number multiplies into the numerator. So 2 times 3n is 6n over n. And then distributing to the 1 times 3n is 3n. Downstairs, when we distribute to the fraction, 3n times 1 over 3n is 3n over 3n, and 3n times 5 is 15n. Now simplify each of the fractions. 6 minus 3n divided by 1 plus 15n, and the fraction is simplified. Let's take a look at b. We're going to multiply by the least common denominator of all the mini fractions. So the least common denominator for x and 7 would be 7x. So multiply the big fraction by 7x over 7x. Distribute to the first term, 7x over x, and distribute the multiplication to the second term, 7x over 7. And then downstairs, I'm just going to write the intent to multiply, but I'm going to go ahead and leave that in factored form. Now let's simplify the numerator. 7x divided by x is 7. 7x divided by 7 is x. And then we have a pair of opposite factors. 7 minus x and x minus 7 divide to give a result of -1. And our end result is -1 divided by 7x. Okay, couple for you to try. Pause the video while you try these. Here's the result for the first one. Now pause the video while you try D. Here's the correct result for D. Okay, now we're going to take a look at some fractions with binomial denominators. Again, we only have these two smaller fractions within the big fraction. They both have the same denominator, so that is the common denominator. Now let's distribute the x plus 1 to the first term, and that's 2 times x plus 1 is 2x plus 2. And let's distribute the x plus 1 to the second term. Here it will be helpful if you can think about the factor that cancels. So when we have 3 divided by x plus 1, when we multiply by x plus 1, the multiplication and division cancel each other out, and that leaves us with just plus 3. In the bottom of the fraction, 1 over x plus 1 times x plus 1 is just 1, and then x times x plus 1 is x squared plus x. Now we have a numerator of 2x plus 5 and a denominator of x squared plus x plus 1, and that trinomial in the denominator is prime and doesn't factor, so this fraction does not reduce. All right, let's try b. Again, we have a binomial denominator. The smaller fractions, we have two different denominators, 5 and k plus 2, so that means the LCD is 5 times k plus 2. So now we're going to distribute to each of the fractions in the numerator. When we distribute the multiplication by 5 times k plus 2, the k plus 2's cancel, and that leaves us with 5. And then when we distribute that multiplication times 1/5, the 5's cancel, and that leaves us with k plus 2, but that k plus 2 is following a subtraction sign, so it needs to stay in parentheses for the time being. in the denominator, we have all factors 5 times k plus 2 times k minus 3. Even though it's tempting to want to cancel those k plus 2's, the k plus 2 in the numerator is not a factor of the numerator because it's following a minus sign. We're not multiplying the 5 on the top, we're subtracting from it, and that makes it not a factor. Let's simplify the numerator. 5 minus k minus 2 is 3 minus k, and then downstairs we've got those factors, and 3 minus k and k minus 3 are opposite factors, so when we cancel them it's going to leave us with a division result of -1. So final answer, -1 divided by 5 times k plus 2. Your turn to try C. Pause the video while you do this. Here's the result for C. Now pause the video while you try D. Alright, here's the result for D. Now we're going to move on to complex fractions that contain negative exponents. So let's take a look at example 4a. In this example, we have 3 times x to the -1. Well, if we evaluate parentheses first, that's 3 times 1 over x. Sorry, we evaluate exponents first. And then x to the -2 is 1 over x squared. Y to the -1 is 1 over y. In the denominator, we have 1 over y squared plus x times y to the -1, which is 1 over y. Let's simplify each of those. So that's 3 divided by x plus 1 divided by x squared y over 1 divided by y squared plus x over y. We can now multiply through by the least common denominator, which would be x squared times y squared in both the numerator and the denominator. So when we multiply our first term, x's cancel, one factor of x cancels, and we get 3xy squared. When we multiply to the second term, x squareds cancel and one of the y factors cancels, which just leaves us with y. Downstairs, distributing, both of the y's cancel, and that leaves us with x squared. And then in the second term, one of the y's cancels, leaves us with x squared times y. We can factor this, and we can factor a y from the first, and we get 3xy plus 1, and we can factor an x from the denominator, 1 plus xy. No factors cancel, so this is a final answer, or you could give the answer as the previous expression. In B, we have 3x in parentheses raised to the -1. That changes the result. That means that the exponent applies to both the 3 and the x, so that's 1 over 3x minus 2. And downstairs we have 5 times 1 over x, which is 5 over x plus 2. Now we can multiply through by the least common denominator over the least common denominator. Distributing to the first term in the numerator, we get a result of 1. To the second, minus 6x. In the denominator, distributing to the first term, that's 15, and then distributing to the second term plus 6x. There are no common factors that can be canceled. We could factor a 3 from the denominator, but that won't result in any cancellation. So that can be our final answer. All right, your turn to try C on your own. Here's the result for this one. Now pause the video once again while you try this last example in D. Here's the result for the last try this, and that is it for the lesson.